apanomba twalalolesha pali simulation ya PLC logic that we have created. Okay, napakubala we're just going to have just this overview of the state of the logic. Okay, so we'll start with basically first the protection. Okay, so just we know the way the system is supposed to operate. So ngamamona mudi network 1, it shows that the emergency push button in station 2 has been actuated, and then of course you notice that the HDR is actually true. So let's see, go to location, let's see what this is all about. So it's a resultant of this function 8 hydroset control. So let's see, HDR, hydroset pressure switch. The hydroset pressure switch is linked to factory I/O. So this is a hydroset pressure switch, which is this one here. Okay, so this one is already linked to factory I/O. Okay, so let's normalize this, and then let's do a system reset. So the reason why it's in this state is because of the way that we're validating the inputs. We said externally we are wiring the hydroset through a normally closed input, so it's true when the signal is fed to the PLC. But the way we validate our inputs, we are essentially negating the signal state of the input. So if it's true externally, our memory bit 21.5 used in our logic becomes false. Okay, so to correct this to be in a normal state, what we can just do is we can actually use a normally open contact, so that we're able to have a normal state. So that's it. Okay, and then of course we need to change the configuration of this so that now we align the logic to what's obtaining. Okay, so this is actually what we get. So the hydroset indication, the hydroset now should be okay, right? So hydroset okay, hydroset okay. So if we actuate the hydroset pressure switch, so now what we have is indicating that there's a hydroset fault. So that, then do a system reset, right? So that takes care of this part. So let's get rid of this. So we're here. Okay, so now we see that actually the system is okay. So the safety relay is okay, and then for the lubrication off-flow interlock, we're talking about 3BD5. So 3BD5, what's the issue with 3BD5? So go to location, right? The resultant is in there. So 3BD5 is actually showing that it's true on account of lubrication off-flow interlock. It seals in through that, and then the result, the cause of this was 4DD2. Okay, was 4DD2. So let's see why 4DD2 seems to be intent on making our lives difficult. Okay, essentially what we're just doing is debugging. Okay, we're just debugging our system. Okay, So here it's showing that the 4DC1 feedback is actually true, which is actually the case because 4DC1 feedback is here. Okay, so initially when you're starting out, the 4DC1 feedback is supposed to come on at the point where the lubrication pump comes on. So these are actually supposed to be in a faulted state, and then when you start the system, when 4DC1 comes on, okay, when you see that 4DC1 indicator lamp comes on, then to help you simulate, you can just actuate the 4DC1 signal simulation. Okay, and then when you see that 281 has come on, then at that point you can come and actuate the 281 feedback button. Okay, so let's see, 281 should be down here somewhere. 281 feedback, it's true, but so 4DC1 feedback to be true, you need to actuate this. Okay, so because right now the lubrication pump is not running, so there's no feedback. Okay, so when the lube pump is running, press this, you get your feedback. Okay, now what do we do? Window protection. Okay, so the safety relay, emergency push, even if it normalizes, you won't get a reset in the system unless of course you do the system reset. Okay, so that takes care of that. And then what else? Okay, so basically we've seen that protection level 1 is fine now. Okay, so now let's look at protection level 2. Okay, so protection level 2, I think protection level 2 is also fine. And then if we talk about sequence control, okay, for sequence control, once we press lubrication off low, press the system start, we should be able to start when there's a flow that latches. Okay, so basically what I'm saying is we should be able to start. Okay, we should be able to start. Now by way of starting, like I said previously, okay, what I said was, in this system of ours, when we press the system start, okay, when we press the system start by way of this push button here, when you press the system start, which is a momentary action, okay, there's going to be a pre-start warning siren, and then up to a certain point, when we see that the loop pump by way of 4DC1 has been energized, at that point we can initiate a simulation of flow by pressing flow 01 and flow 02. Okay, or rather, when 4DC1 is indicator lamp comes on, we can energize the feedback. We can simulate a feedback by way of 4DC1 feedback. Okay, because right now 4DC1 is not true. Okay, 4DC1 feedback is not true, so we need to come and actuate the 4DC1 feedback when 4DC1 is energized. Okay, and at the point where the indicator lamp 281 comes on, we also need to actuate or energize the 281 feedback. So starting sequence, press the start push button, the alarm comes on. Then at the point where we notice that this 4DC1 lamp comes on, we need to actuate, or we need to push down on the emergency push button to simulate a feedback condition. Now, because the lubrication pump is running, we need to energize, or rather we need to push or simulate a flow by pressing the buttons flow 01 and flow 02. Okay, and then at the point where we see that 281 indicator lamp has come on, we need to come and press the 281 to simulate the feedback for the power contactor for the main drive. Okay, so essentially what we're saying is this: the normal operation of this system, for you to operate, you basically need to select the operational mode. So are you going to run the lubrication pump in the normal state or test position? Okay, so under normal conditions, the lubrication pump needs to be selected to run in the normal condition. Okay, as can be seen from I think as can be seen from which one? As we can see from lubrication pump normal select, clutch timer. Okay, as can be seen from network 4. Okay, that the lubrication pump needs to run in the normal select position. So we put the lubrication pump in the normal position. Okay, and then for the main drive also, we need to determine the operational state. So the main drive can operate in the normal state or in the test mode position. So in this particular case, we are running in the normal mode. Okay, now what we're saying is that the sequence of operation, okay, the sequence of operation is such that when we press the system start, okay, there's going to be a pre-start warning siren. Okay, and then when the pre-start warning siren starts after a predetermined time or after a predetermined duration, the lubrication pump is going to come on, and because the lubrication pump, as simulated by this indicator lamp 4DC1, has been energized, right, we expect there to be a feedback coming from the power contactor for the lubrication pump, which we can simulate by way of actuating this push button, right, as feedback. Okay, and then similarly, when that happens, because 4DC1 has been energized and there's feedback, so you expect that to be a flow, which is why now these two push buttons come in to simulate the flow. So you need to come and press this, and then of course you simulate the flow. Okay, and thereafter you would notice that the 281, which now controls the crusher main drive motor, is going to come on. This lamp is going to come on, and then when it does come on, what's going to happen is you expect that to be feedback. So at that point, push down on the 281 feedback. Okay, so what I'm saying is the following, right? So system start. Okay, pre-start warning. So when this is true, the loop pump is on, so we expect that to be feedback, and then we expect that to be a flow. Okay, so when there's a flow, at some point 281 is supposed to come on, so 281 feedback is supposed to be true, and the siren comes off and the system is running. Now, because these two conditions are on, there's what we call the vibrator interlock. Okay, there was a vibrator interlock which should be right about here. Okay, so the vibrator control interlock, because this is true, the vibrator should be able to run. So we can pick vibrator number 1, and then we can select that we want to run vibrator number 1. Okay, and because that is done, the only thing we need to do is start. Okay, so should have done a better job with with. 'Cause, 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 Okay, so this is basically the start. Okay, so for AB001 should be the start. So what's the issue now? And so let's see why are we not able to run the vibrator. Okay, why is vibrator 1 failing to run? So vibrator, okay, so protection wise everything is okay, the power switch is okay, the isolators are okay, the vibrator 1 is selected, the vibrator 1 local stop, this is fine, the remote stop is also true, the interlock is true, and then vibrator power contactor feedback. So let's see what your issue is. Okay, power switch operated, vibrator fault, okay, SDR vibrator remote start. So this one here is where our issue lies, because we're not able to seal. Okay, we're not able to seal. I don't know why I didn't see this initially, so I think our problem is right about here. The problem is right here. So problem is in that position, and I do hope we won't have to reload the block. I hope not. Okay, so I hope this is where the problem was. Okay, and then where do we need the feedback? Yes, I think this is the location where we need the this is where we need the feedback. We need to sail in through the feedback signal. Okay, we need to sail in. We need to sail in through the feedback. So if this is feedback, okay, so I think this is fine. Okay, so basically what we're saying is, for us to be able to run the vibrator, we need to select the vibrator. So vibrator 1 selected, and then to start the vibrator we just press this one here. Oh, okay, because we don't have the feedback. So in this particular regard, okay, I'm just, for you to be able to run the vibrator, because you need to sail in through the vibrator power contactor feedback auxiliary contact. Okay, so which is why you need to have that feedback. But this is not really going to help us properly simulate the operation of the vibrator. Okay, so what I'm going to do is I'm going to get this and then use it as a sail-in contact. Okay, we shouldn't do this, because if you're going to sail in the output, it needs to be sealed in through the auxiliary contact of the power contactor that you're trying to control. Okay, so but in this regard, because of the difficulty associated with having to simulate our vibrators, I'm just going to do this for test purposes only. Okay, this is purely for test purposes. So now what it is once we select the vibrator number 1, and then we just need to press the start, and then vibrator 1 will be shown to run. Okay, so like this, vibrator 1 is running. Now if at all there was a fault by way of earth leakage or maybe the paddle switch, you notice that the paddle switch is operated indicator and the system actually is faulted. Okay, so even if we normalize, and you notice that this doesn't in any way affect the main drive. Okay, the lubrication pump is still running and the main drive motor is still running. So the vibrator operation, when it gets to be faulted, it doesn't affect the other parts. Okay, so now you see that paddle switch operated and the system is faulted. So what we do now is or maybe we can also make a minor adjustment. Okay, we can also make a minor adjustment in the sense that the operation of the vibrators does not in any way affect the other system. So what we can do is we call this vibrator reset. Okay, why we're just going to call this as a vibrator reset, ladies and gentlemen, it's because of what we've just observed. So drivers, normal input 3.7. okay, so vibrator reset. So vibrator reset, input 3.7, and then of course we're going to come into step 7, and then symbol table, and as far as the memory bits go, we went as far as memory bit 13.4 for the normal inputs. Okay, so insert symbol, and then we're going to call this as vibrator reset. Okay, no need for the comment because it's self-explanatory. Okay, so I'm going to just copy this, and then I'm going to come to input output mapping, and then under normal inputs for vibrators. Okay, input mapping. So I'm going to say and input 3.7 is going to pass its state to vibrator reset. Okay, like so. That's what we get. So reset, vibrator reset. Okay, vibrator reset. So let's save and download, or rather download this to the PLC simulator. Okay, so apparently if you do a system reset when the system is running, you also reset the running state of the system. Okay, so basically to start the system you need to select the operational mode of the pump and the crusher main drive motor. So normal mode for the lubrication pump, normal mode for the main drive motor, and then you press the system start. Okay, so you press the system start. So you press start, you get the pre-start warning siren. At the point where 4GC1 indicator lamp comes on, you simulate a feedback, then you simulate a flow. Okay, like that. Simulate a feedback, then simulate a flow. When 2AD1 comes on, you simulate a feedback, and the siren comes off, like so. The siren stops, so the lubrication pump is running, and the crusher main drive is also running. Okay, then we move to the lubrication pump. Okay, so for the lubrication pump, you notice that the selection needs to be made for which vibrator you want to run. So if we say vibrator number 1, vibrator number 1 is selected to operate. Okay, and then the only thing you need to do is you need to press the start. So like this, vibrator number 1 is running. Okay, so if you simulate a fault, vibrator number 1 becomes faulted, like so. And then the only problem that I've noted is that if at this point, because we need to reset the faulted state for the vibrator, right? And we know that input validation can only be reset, okay, by way of the system reset. So because we want to just limit this to the vibrator reset, so we need to make a minor adjustment in the input validation. Okay, so we need to come to input validation and then look at the reset. Initially we had system reset. Okay, we had system reset, like right here. Okay, this is where the vibrator number 1 input validation and vibrator number 2 input validation had to do with the network 4 and network 5. So we need to make some minor adjustment to this. Okay, and then you need to realize that the reset is purely limited to the bits being pushed to memory word 1008. So these two addresses, this one here and that one. Okay, so the thing that we need to do a localized reset for these, we're going to copy this. Okay, then we're going to paste it there. Oh, come on. Oh, all right. And then this one here, I'm going to say vibrator reset. Okay, vibrator reset by way of memory bit 13.5, and then I'll need to move these values not to memory word 1008. I need to reassign memory word 1008. The last memory word we used was memory word 1026. So 1028 is open, right? So we're going to get this, and then now you notice that I'm only adjusting the logic for the vibrators. Okay, and the reason being that the operation of the vibrators is independent of the operation of the main drive and the lubrication system. A fault on the vibrators will not affect the operation of the crusher and the lubrication pump. Okay, so I'm going to get this address here, and then I'm going to edit it to memory word 1028. Okay, in both logics for the vibrator 1 and vibrator number 2, and then the reset also I'm going to have to assign in this one where it says vibrator reset. I need to reassign these addresses. Okay, and then I'm going to save this, and then I'm going to download. Okay, like so, and then we can check if we're online, which we are. And then when this is done, the only thing I will need to do is to come back to the vibrator, okay? Vibrator number 1, which is reset as at now, right? So if I'm saying if I press the start, the vibrator is able to run, okay? Then if I simulate a fault like so, the vibrator becomes faulted and the indicator lamp stays until we do a reset, okay? And then of course the main drive is still running and the lubrication pump is still running. So that's the only separation we've done. And then of course if you wanted to run vibrator number 2, you choose or select vibrator number 2, and then of course you press the start for vibrator number 2, okay? You press the start, and then of course vibrator number 2 is running. You can simulate a fault. So why isn't 4BE3 giving us choice? So for 4BE3, how about 4BE2? Okay, let's see. 1022.0. 1022.0 is coming from this one here. Then 1022.0. It's given to memory bit 2006.0. Then the reset is 1028. So vibrator reset is where the problem is. So let's see. Vibrator reset. What's the normal state of this? Normal state of this should be momentary. Okay. Should be momentary. Vibrator reset. So we've got the vibrator reset with a momentary action. Okay. I'm believing this was mapped to input 3.7. So vibrator reset was mapped to input 3.7. And then let's see. Okay. So I take it this works in our favor now. So select vibrator number 2, and then thereafter we're just going to press the start for vibrator number 2, like so. So vibrator number 2 is running, okay? And then we can simulate a fault. So vibrator number 2 is in a faulted state. And then of course the main drive is still running, okay? So you notice that the lubrication pump is still running because the indicator lamp is on and the main crusher motor is also running. And then of course, to reset this system, okay, to reset this system, you can do a system reset or a vibrator reset. Okay, you can do a vibrator reset. So hopefully the drive is still running. Okay, we're still running. And then of course the vibrator is off. So again, we can start. The vibrator runs. We simulate a fault. Okay, maybe the vibrator 1 part switch is actuated. Okay, like I'm not able to zoom in beyond this. Okay, so vibrator 1 part switch is this position. Okay, so if I press this, part switch operated, there's a system fault. Okay, so we normalize. Of course I left the reset on the other panel, so reset. Okay, so this is how this thing is supposed to work. And then of course you've got your the lubrication system is running. Okay, don't know if you can clearly see that. The lubrication system is running, the crusher is also running, irrespective of the operational state of the vibrators. Okay, but the only issue I have, okay, I just thought of this later, is that the hydroset is never supposed to run when the crusher is running, but the way it is. Okay, so what happens if we try to raise or lower the hydroset? It's going to raise and then it's going to lower. This is not supposed to be the case. Okay, so just as an afterthought, we can modify the system in a way. Okay, so we're just going to come to here, then we're going to stop the system. So we're just going to say stop. Immediately the crusher main motor stops, but the lubrication system is going to run for some time. Okay, for like maybe 30 seconds from what I remember. It's supposed to be 30 seconds and the lubrication pump switches off. Okay, so that's that. So switches off, and then what we're going to get is we need to block the operation of the hydroset. So in sequence control, okay, in sequence control, you notice that the sequence control relay is always energized when the crusher is running. So we're going to borrow this address. Okay, and then we're going to go to where it says hydroset control, and then in hydroset control, what we're going to do is we're going to interlock this position. Okay, in this position we're going to get a normally closed contact, and then we're going to paste that address, save this and download. Okay, so that the hydroset never runs when the crusher main drive motor is energized. As the system start, we look out for 4DC1. Okay, when 4DC1 comes on, we simulate feedback, and then we also simulate a flow. When 2AD1 comes on, we simulate a feedback, like so. The siren comes off. So the system is already running. Okay, and then we're now going to go to the hydro set. I think this is it. This is our no, the hydro set is the middle one. This is our hydro set. Okay, because previously, if you look at this, now we can't run the hydro set, because even if we say hydro set raise, nothing happens. Okay, nothing exactly happens. So for the only way you're going to run your hydro set is if you put the system into normal stop. Okay, so 3BD1 is de-energized, and then of course in this state you should be able to raise or lower your hydro set now. Okay, so after 30 seconds, this lamp or indicator light or pilot light is going to be de-energized, like so. So now we're able to run the lubrication system, we're able to run the crusher main drive motor, we're able to run the hydro set, and we're able to run the vibrators. Okay, so hopefully this has been helpful. And I know at first glance it may seem like a whole lot of complicated shenanigans, okay, but you eventually make sense out of it. Okay, and the reason why I usually prefer to work with memory bits as opposed to actual mapping of physical inputs, mapping of physical outputs, because it affords me the opportunity to design the circuit irrespective of the physical output address assignments. Okay, and additionally it's more flexible. Okay, it's just actually more flexible in my view. Okay, so we hope what we have covered fyala myafwirishako ukuchita understand ama PLCs, so that ngamule isambilisha mwebene namkwata complete circuit olo namwishwa nofyo ile bomba. Okay, kale bali kamkwaye.